All right, 7.1, the laws of exponents. So here's one of the first laws. We're going to review your grade 9 and your grade 10 exponent laws. So the first one is known as the product law. The product of two powers, so here they are right here, two powers with the same base, you will add those exponents, known as the product law. So that's example of that is 2 to the power 3 times 2 to the power 5. Simplified will give you 2 to the power of 8. And if you're asked to evaluate, you would then give the answer 256. And an example with variables, m to the 5 times m to the 2 is equal to m to the 7. This is known as the product law. A to the m divided by a to the n is equal to a to the m minus n. An example of that is 3 to the 8 divided by 3 to the 5. As long as the bases are the same, we can subtract the exponents. Oops, too much information there. Let's backtrack a bit. So this is called the quotient law. So back to where we were before, this is known as the quotient law. So I can take m take away n. 8 minus 5 gives us 3. 7 minus 4, 3 gives us 4. So the idea, as long as the bases are the same, we can subtract the exponents, known as the quotient law. Next, you're given a power, so a power within a power. What that means is that you will have the same base, but you can multiply the exponents, m times n. So an example of that is when you have 2 to the power 3 all raised to the 2. What do you do here? Well, you take 2 as your base and multiply the exponents to give us 6. 2 to the power 6 results in the answer 64. Well, what happens if we have variables? Let's say m to the 6 to the n. What does that result in? Well, m to the 6n. This is known as power of a power law. Next one. M times n all to the power of t. This will result in m to the power t, n to the power t. What you have to do there is distribute. So you're going to take the t and distribute it to everything inside when there is a product or when there is a quotient. So you are not allowed to give it if it's a plus or minus. But when it's a product or a quotient, you can give away the exponent. This first one is known as power of a product. The second one is known as power of a quotient. What will that result in? Power of a product is when you have a product and you raise the power and expand that. And the second one, when you have a quotient, you take the power and you give it to each part of the quotient. All right, let's look at some examples. Example 1. Write each as a single power. 5 to the power 2 times 5 to the power 8. And then the second one, part B, and finally part C. Part A. The result here, write each as a single power, is 5 to the power 10. The second one, the result here, will be 7 to the 9 over 7 to the 5, which results in 7 to the power 4. Finally, the last one will be 8 to the power of 2 times 3 times 5, which is 8 to the power of 30. So these are the 3 examples where you're just asked to write as a single power. Next, example 2. Simplify, then evaluate. 3 to the power 2 times 2 to the power 5 times 3 to the power 5 times 2 to the power 7 over 3 to the 6, 2 to the 8. What do you do here? Well, it's important to combine the things that are similar. So 3 to the power 2 and 3 to the power 5 in the numerator turns out to be 3 to the 7. And 2 to the 5 and 2 to the 7 turns out to be 2 to the 12. On the bottom, you have 3 to the 6 and 2 to the 8, and we can use the quotient law. Quotient law, we subtract, so we have 3 to the 1 times 2 to the 4. 3 to the 1 is 3, folks. 2 to the 4 is 16, and then we can evaluate 48. So this is an example of how to deal with complicated questions with our mixed powers. All right, example number 3. Write 4 squared as a base of 2. How do we do that? Let's go back a step. All right, so we write 4 squared as a base of 2. What that means is I need a base to be 2. How can 4 be written as a base of 2? 4 is equal to 2 squared. So we replace 4 with 2 squared. The base is 2. We don't worry about what the exponent is. I could have had 8 squared there. It would have been 2 cubed. So the idea is we have to write as a base of 2. So we have 4 becomes a base of 2, 2 squared, and then you had that extra square that came from the original question. Well, that simplifies itself to 2 to the power of 4. So we can convert different powers to different bases if we need to. Why? Well, let's look at the next question. Example number 4 says simplify, then evaluate. If I give you a question like 3 squared times 9 cubed divided by 27 squared, what do we do here? Well, these are different bases. Can we make these have the same base? Because if we can, then we can use the exponent laws. Well, folks, 3 is our smallest number there, and I definitely can make 9 become 3 squared, and then we leave the cubed out here, so this 9 that's here becomes 3 squared, and this cube that's here stays cubed over here. On the bottom, we have something gives us a base of 3, which will be 3 cubed. That's our 27. Don't forget the square, and now we've converted everything to a base of 3. By doing so, we can now simplify. 3 squared times 3 to the 6 over 3 to the 6, and the result will be 3 squared. 3 squared is 9. And this is example A. Let's look at the next question. All right, looking at the top, how did that change? Very important that you note here, even if I wrote 4 to the power of m as a base of 2, I could take 4, still convert it to a base of 2, and with the m exponent, you multiply those two across. All right, part B. 9 squared times 81 cubed times 3 to the 4 over 27 squared times 3 cubed to the 4 times 243. Write everything as a base of 3. So we have 3 squared, 81, and don't forget it's 9 squared originally, so it's 3 squared squared. 81 can be rewritten as 3 to the power of 4, all cubed. 3 to the power of 4 stays the way it is. The 27 that's here can be written as 3 cubed squared, and 3 cubed to the 4. We can simplify that to 3 to the 12. And 243, lo and behold, folks, turns out to be 3 to the 5. What can we do here? Well, we have everything in the base of 3, so we can use our exponent laws, and we can collect like terms. Now note here, we have 3 to the 12 and 3 to the 12, so those guys will cancel each other out. We have 8 up here, 11 down here. So this 4 will cancel with 4 of these. We have 2 left. This 4 will cancel with 4 of these from the bottom, which we have 1 left. How many will we have on the bottom? Well, we will have 3 on the bottom. Now, some of you are going, 20 minus 23 is negative 3. Why is the answer positive? Well, remember that we want the answer to be positive. That's going to be something where you need to simplify. The result will be 1 over 27. So this is a positive exponent. We're going to look at negative exponents a little later on. All right, that's the end of the lesson, folks. Hopefully that's enough. Take care. See you soon.